Good morning. We're going to discuss about exponential function transformation for this day. We're going to analyze exponential functions in terms of its key features, attend to precision, and do critical thinking. Let's first go to one of the applications of exponential functions. In this case, is for uh, spread of diseases, like for example H1N1 cases, not only in Mexico but in almost all other countries as well. And at this moment, we're dealing with our pandemic regarding our coronavirus cases, infections. It's also dealing with a lot of different applications in terms of interest or compounded interest with money, investments, loans, population, nuclear reaction, half-life, and a lot of other stuff in real life. And recently, with our coronavirus pandemic all over the world, we're talking about flattening the curve in terms of dealing with isolation, quarantine, and social distancing. Now, an exponential function is any function wherein exponential function is any function wherein our independent variable x, again, our independent variable x is always on the exponent, and the whole function for our exponential will always look like this in here. As we see, we have our x on our independent variable. We have our signs positive or negative. We have our terms a, b, c, and d. This time, we're going to deal first with our c component on how we can move our exponential function either right for positive, sorry, right for negative, or left for positive. So as we can see in here, an exponential function always looks like this one in here with our dashed line as our horizontal asymptote. A horizontal asymptote is always that line that the exponential function tends to go to but will not cross that asymptote line. Again, an exponential function always have a horizontal asymptote. Let's now go to our first problem in here. So our first problem, it says here, this is the function in blue, 2 to the x minus 5. What we want to do in this case, so as we can see at point x equals 5, it started to increase. So that means from the origin, it goes 5 units to the left. That's why it's a minus 5 in there. What we want to do is to, for the function to actually pass through all of those stars using that purple ball in there. In that case, I have to move it now. In this case, how many units to the right instead? So I would say I want to move it in such a way that it will start going up somewhere near 15. So in this case, what I would do is to put it somewhere here, where it will traverse everything and started to increase at 16. So I would say I would put it somewhere between 18 and 19 to the right from the origin. So I would say negative 18. So let's now try to change this one. Instead of negative 5 or minus 5, I'll put it at minus 18. And see, it looks like it's going to pass through everything in there. Obviously, if you make it to the right some more, like on a 20 or 24, it will be kind of too slow already. Let's go to our next example. So it says here, change two numbers in the row below to fix the marble slide. So our purple marble is in there at 12, 0, 12. This our blue is our 2 to the x minus 1. And it says it goes from -7 to the right. In this case, what we're going to do this time is for it to pass through all of this in here. So in that case, if I wanted to pass through on those four stars, the horizontal asymptote should be in there. Now, if I want to deal with my horizontal asymptote, I'll be dealing with this letter D in here, a number added to or subtracted to our exponential function. So it's plus for moving up and minus for moving down. That is for my horizontal asymptote. So going back to my problem in here, then in this case, I would want to put my horizontal asymptote at this value 3 in there. And also, since I want it to pass through all of those points, then it should not start with -7 going to the right. I want it to start at -14. So let us do this one in here right now. Again, in this case, I would put my horizontal asymptote. Instead of -1, I'll put it at +3 so that it will, the horizontal asymptote will be there at 3 or at y equals 3. And I want my value to start not at -7 but at -14. And let's try to do this. So as we may see, the balls now actually pass through all of those four stars in there. Let's now go to our next question in here. So it says this blue is the graph of t to the x plus 2, but we want it to pass through all of those four stars with our purple ball on that side. So what do we do in this case? We want to extend our blue graph or flatten it along the vertical side. So we want to do it as such in here in a way that it it will still have the same it will still have the same y horizontal asymptote, but it should be flattened a bit so that it will pass through all of those four stars in there. So we want it sort of like a vertical compression. And in order to do that, go back to our exponential function transformation. We want to do it in such a way that our b, in this case, should have a horizontal compression, or sorry, that should be a horizontal expansion. In this case, you want it to expand horizontally like such so that it will look like this in here. Sorry, we cannot see the visual in there. So in that case, let's have our b as either a fraction or a decimal less than 1, but still a positive number. So meaning its magnitude is still the same. So in this case, we just want to have this in here, something where b or absolute value of being there is less than 1. Going back, let's try this one now in a sense that I'll put in there for x, multiply the x by a value less than 1. So for example, 0.1, for example. As I may see on the 0.1, the only problem is that the purple ball is still at the bottom in there. So I would say a number still less than zero point 0.1, but close to it, I would say 0.09. So I would say on 0.09, it is perfectly in there. Let's try to check it out. So I was seeing here that at b equals 0.09, the function actually had a horizontal expansion. Let's go now to this particular example here. The graph in blue is the graph of 3 to the x plus 1. So as I may see, it's increasing and it's also having a horizontal asymptote at positive 1. However, as I may see from the stars, it's going kind of reflected along the y-axis with our purple ball in there. So if you reflect this stars with the blue along the y-axis, then it should solve for it. Let's see what we mean by that. So if we see a y-axis reflection, we just want a y-axis reflection. In this case, this graph in here would look like this graph in here. And in order to do that, then we should just make the exponent negative in there. Let's try if that will work on our example in here. Again, we want a 3 to the x plus 1. The x, I'll just make it negative. Let's try to do that one in here, making it negative. And in this case, it would pass through everything. And as you may see, that is corresponding to a y-axis reflection. And our last example in here, so as we may see, this graph in blue is our 3 to the x plus 3 with a horizontal asymptote at y equals 3. But what we want to do right now is to, for this graph to pass through all of these 4 stars. And as you may see on the 4 stars, it has now its horizontal asymptote somewhere. It starts to go horizontally in here at y equals 2 instead. And it needs to be um, reflected along the y-axis. So there are 2 factors in here. First is the horizontal asymptote changing to 2 instead of 3, and a mirror reflection along the y-axis. So going back to our graphic organizer for our exponential function transformation, we're going to do our y-axis transformation, y-axis reflection, making it negative in here, and also the D, where we change our horizontal asymptote to a positive 2. Let's try to do that on our example in here. So therefore, I'll make this x value negative. Sorry. I'll make the exponent negative x instead of positive x for a reflection along the y-axis. And instead of positive 3, I'll want to put it down to a positive 2 instead. And let's try to do this one in here right now and see if this will work on our case. It does work on our case for this particular example. As for your example, you may try to do this in here, 2 to the x minus 4 minus 3. If you change the negative 4 to a positive 4 in the equation, what would happen to the... Let me know if you have questions regarding exponential function transformation. And once again, tell me QUAN-do, you can do math.